All right, recording has started. Want to let everybody know, it seems like a lot of people stayed from the prior talks, but anybody new, if you have any questions for Robert at any time, please drop them in the Q&A box at the bottom of your Zoom screen, and he will be able to see those questions during Q&A time. And we're going to do Q&A since this session goes until 1:10. Do Q&A at around about 1 o'clock. So, Robert, it is my privilege to introduce you today. So, Robert, you design and you develop application integration solutions both on-prem and in the cloud. Traditionally, the solutions were based on the Oracle middleware stack, but lately you're advising solutions that use a more cloud-native or hybrid approach. Besides application integration development, you're an advocate on blockchain, IoT, and microservices. You're heavily involved in the developer community. You are an international speaker at many conferences. You're the author of 2 books. You're a blogger, and you participate in tech-related podcasts. And for all of this amazing work that you've been doing in the community, you were awarded the Developer Champion title in 2017, which was renewed from 2018 to Oracle Groundbreaker Ambassador. So you are doing big things, doing amazing work. So Robert, with that, I'm gonna mute myself and I'm gonna hand it over to you.
No, thank you. Thank you for this nice introduction.
Yeah,
welcome everybody for this last session for today. In this last talk, I will go over, around 10 reasons to choose Apache Pulsar over Kafka, and specifically on the topic of event sourcing and CQRS. And let's go. So you can follow me on LinkedIn or on Twitter if you want. There's also a reference to the 2 books I wrote. One is really on integration platform, and the other one is on blockchain. But for this talk, I want to first go over a little bit about concepts about event sourcing and CQRS. Then take a look at some common problems with Kafka-based projects and how that relates to event sourcing. Then a small introduction now of everybody that we here know about Pulsar. That's what one thing I think with all the many presentations we had today, I don't have to go over a lot. And then we look at the reasons why I think that Pulsar should be your pick if you are certainly want to implement these 2 concepts and certainly the CQRS pattern. So first, let's look at what those 2 are, right? What's event sourcing and what we mean with CQRS. So if you look at this this picture, this is a picture of an event-driven architecture, and what we see is that it doesn't matter what device you have. If we have a laptop or a mobile device, when we communicate with a web application and we do a change on maybe on some information, or we do what can lead to a state change of a certain data object. Only this state change is published by an event, and publish once, subscribed by many, right? So if it goes to the backend or a monitoring app or the search app or any maybe a data store for cold storage or later to use, this is like if we look at event sourcing, right? I think with now what you see maybe today, this concept should be familiar with you. So event sourcing uses like any event-centric approach to persist these business object states. And this business object is persisting by storing it in a sequence of state-changing events. So instead of having like a constant, maybe an updated object that we send. We only send the changes, and to be able to get the latest state, we need to process all these state changes. And whenever a state change, that new event is appended to the sequence, and we need to, of course, then repeat all the events to get the current state. But for any consumer, any application that uses the date and end date, all these events should be sufficient to reconstruct the final object state. So if we then look at CQRS, CQRS stands for Command and Query Responsibility Segregation. This means that all the write interfaces and the read interfaces are really separated from each other. The responsibility, they have their own responsibility. So where we have our write interface, it goes to the event queue, which leads eventually to the storage on the event store. And there we can process the data through event handlers. And the event handlers, they can store maybe a different view, a different way in the application state. And from there on, you have the interfaces to read that state. If we then look at the pattern itself, so what I said is that if you develop this pattern in the software, you really separate the writing and the reading of the data objects, the responsibility of that. So the bits of the system that are responsible for changing the system state are physically separated from the bits of the system that manages the views. And if you would compare that to a traditional CRUD architecture, then this is implemented by the same component. That can be like a microservice that has multiple operations. It can even maybe be a database package that has or any interface with read and write operations. And there it has both responsibilities to read and also to write the state changes. So why we use event sourcing and certainly CQRS, why it's a good pattern, is because in this way we can have better scalability. And certainly if we look at why we go for Pulsar instead of Kafka, this is one of important things, scalability with CQRS. So the read side is separate from the write side, so each can be scaled separately from each other, and that's why we can optimize the performance independently. In other cases that we can simplify the way we write the data and we read the data. They can be separate data models, right? A command can be much simpler than the view, the read logic that we have. It's also more flexible. So because we have clear separation of the methods, we can also easily change things. If we change the commands, then we can still go to the same materialized view. Or if we have new commands, we just have to add. We can add a different view, or maybe separate, or change the view separate from each other. Right? You can change the commands first and then the views, for example, or vice versa. And with this, we can also mostly focus on the business side. So if we want to make something more, applications are more responsive and more easily adjustable. If there's a change, the change is also cheaper if we separate the commands that's coming in from the queries. And why, in this case, Pulsar would be a better solution, a better choice. So maybe some of you people have seen this picture maybe today before, or maybe you will see it tomorrow. It's a very, I think for this one, if you search on the differences, is a very famous picture. It's from October 2018 already, so it's almost yeah, it's 1.5 years old, maybe almost 2 years old. So the main problem is with Kafka scaling. And if you want to add maybe a new broker in your cluster or edit something like that, it is there, but before you can use it, always the data needs to be rebalanced and needs to be synchronized between the brokers and the state. We see that in a moment why that is, but in this case, Kafka uses distributed logs, where Pulsar uses more distributed ledger, where if you want to use like the new boat, if it's there, it needs to be synchronized fully before it can really participate. So if you have a lot of events coming in and you see that the load is high, you need to be able to scale. And if you go to another parallel universe here, you see that if you do that with Pulsar and you add a new broker or you add something in a new cluster or a totally different location, then once it is ready and starting, it's already directly participating. So instead of saying, "Oh, we're doomed," right? With Kafka, we can production will just continue working if you use Pulsar. So let's break that down more, right? So if you use Kafka, scaling is really difficult. And that's the way Kafka stores data within the broker. So the broker is stateful and it uses distributed logs. So a log can be very big and grow over time because it's like it uses for the whole persistent storage. One thing is that if a log starts to grow and grow, sometimes you want to partition things or say, okay, this partition is maybe 1 gigabyte big or 2 gigabyte big, or it's a little bit of how you size your logs, how big you want to have them. But if you want to partition them and make them, or if you want to change the partition size, that can take time. Certainly if you have a lot of messages in the logs and also maybe the amount of brokers, it can mess up the message order because it takes a lot. The synchronization can take a long time, but also if there's still coming a lot of events in then it can get delays, or one broker receives the messages in a different order than the other one. And if we look at CQRS and the way you need to rebuild your state, it's really important that doesn't happen, that we don't miss any message or that the message order stays the same. If we get updates, if it can mess up the end state of the data. So be able to not have that with Kafka, we need to plan and calculate the number of brokers, maybe the number of topics, the partition, the sizes, and also how we want to do that to avoid the scaling problems. So I'm working at a customer that now has 70 million events per year. But next year or in 1-2 years, the planning is to go to 1 billion messages. So if we would have used Kafka in this place, then we would already need to have the brokers and the partitions already in place to handle the 1 billion messages to avoid this problem. Same goes for if you have multiple clusters, you want to rebalance that, it just has impact on the performance. And then it has impact on the producers and also the consumers. If we look at development side, because that's also 20-25% of my daily job is still on the development side. We have no native authorization on the events and commands that's coming in. And that's really important, that you don't send like unknown commands, right? And we also don't have, with Kafka, we don't have like a native event analyzer. Yeah, we have a Kafka streams, but that's very limited. You can slide over some information, some data. You can you batch some events and do some processing on that. But if you really want to do action-based things, we need to already go to Apache Spark or Heron. Then Kafka, if you want to do geolocation, it's also problematic. If you just have two data centers, maybe it's the latency between. You have the same problem about when it's delivered, and maybe you can get a complete loss of data because the order is like messed up. So let's switch over a little bit to Pulsar then. Why would I, for this situation, certainly from 70 million to 1 billion events, why is maybe for this case Pulsar a better option? So two things. I think this is some slide I just go quickly over. I think most people, you all know these things. This is if you do Pulsar, you know these things and know this. Both Pulsar has both the high performance streaming, so what also Apache Kafka pursues, and we have the flexible queuing mechanism where we can do policies, or we can say who can read, who can write, what kind of validations we want on, for example, the message, or we want to process things when the message comes in. And using the unified message model and API, so it doesn't matter if it's a persistent queue or it's a topic, we can use the same API. The other things, right, where you see differences, I want to go over these. Like most things Kafka just doesn't have, and I want to go over some of these. So what Pulsar has the data replication and syncing to disk through not the broker but to bookkeeper. So that's why it can be it's durable. The events can come in without breaking this the syncing of the data. Interesting other things where I want to be more focused on is the tiered storage, and why that is important for CQRS, the warm and the hot cold paths. Pulsar functions, I want to address that one, certainly if we are processing information, so very lightweight compute. We can do the things like the scalability and the throughput on the partitions. We can do 1.8 million messages on a single partition. So, and it's easy to add a partition without having to wait on the sync or changing partition size. With the 10 reasons, I have most of them very clearly worked out. Some are more generic, so we can go over them already. Some of them already talked about. So then we have some time also for more in-depth questions if they are there, or maybe a small demo. I have also something there. So let's first go to the first one, and why I think that in this case Pulsar is better for the job than Kafka. So if we look at the first thing, and the main thing is streaming and queuing come together. So Kafka is only an event streaming platform, and it's very good in that. It's don't think about any less of something like that. Kafka is really good in it. We use it in multiple customers. But it implements only the concepts of topics. The pub system, we have the permanent storage. We can do process of event streams with Kafka streams, but if we want to do multiple things, we need a stream processing engine separate from that. We can still do message validation using Avro. So we have it there, based on distributed commit logs, and still capable of handling a lot of events a day. But if we compare it with Pulsar, and what we get out of the box, right, is that we see that it started as the messaging queuing platform, and additionally we have the high rate real-time event sourcing use cases, because it's the same functionality Kafka also provides. It implements concepts of the topics, right? The pub sub, but instead of having like permanent storage, we also have distributed and cold storage. We can do event processing out of the box, and we have multiple message validation schemas. Also includes Avro, so if you go from Kafka to Pulsar, you can still use the same schemas, but also JSON and some other things I'll go in more detail later. With that, we can also do like, we have the queuing patterns. Kafka doesn't have that, so you can play a little bit with competing consumers. You can also do failover subscriptions. You can say, okay, this message go to multiple consumers. That can be possible. With Kafka, that's not really a thing. When you have, you can have separations with consumer and consumer groups, but you don't have the more advanced subscription-based message patterns. And it uses a distributed ledger, or it uses the log segments. So instead of copying over completely the log file, if you want to expand, it's using the log segments. So if we continue on that, the log versus the distributed ledgers. So Kafka logs are append only, and they are sequential. So the data can be written to and be extracted from the logs very quickly. And that's a plus for Kafka, right? And that's why Kafka makes it also good. But they are simple logs, and you can get into trouble when they get large. Not only on storage, what I mentioned on the scale up and scale out, and the replication. So if we go back to the concept of event sourcing, CQRS, it's important to distribute events quickly to all consumers, even when the loads get high. We don't want the problem of timeouts, or that some consumers take events quicker than the others. And with Pulsar, Pulsar avoids this problem. Instead of copying all the large logs, right, it's breaking down the logs into segments. And it distributes those segments across the multiple servers, while it's being written down, right, to Bookkeeper for the storage layer. And you see that here in a little bit in the architecture, right, is that if a producer sends a message to a broker, then the segments are coming in, the messages that coming in are placed into segments. And this is something you can compare also a little bit with blockchain. So we have a distributed ledger. Every block has transactions. Here we have also the ledger has segments, and we have the messages there. So really the similar concept. So if you understand the concepts of how this works, you also easily should have understand blockchain. And you see here that we have multiple bookies also in Bookkeeper, and you see that not all segments are written to the same bookie, but eventually you get the segments synchronized. So, but we still have the things on the bookie, right? So all the segments, it's still growing and growing, right? On your storage in the Bookkeeper. And another thing that if we check for event sourcing is the tiered storage. And for event sourcing, it's important to be able to replay the messages, right? So if my application is broken, something happened, we can unexpected exception, we maybe want to do a build and destroy mechanism. So we remove it and we replay everything from the beginning. Or there's a new application, right? A new consumer, and it replays the messages. So, but keeping all the messages forever on the same storage, it sounds great for that, right? We put something there. We can read all the messages. The only problem with Kafka is that it's bigger, right? It's one log file. It's very it's always stored in the broker. So with Pulsar, I would also suggest always to have some kind of tiered storage policy there, where we can automatically push old messages there. Maybe we say everything older than 2 weeks, we put it in a cold storage. And that can be the cloud storage, right? Or maybe on a network storage somewhere if you run it on premise. And with that, we can still retrieve them just like those newer fresh messages. And that comes because we have like the unified API, so the consumer doesn't see that it's in the cold storage. But you see it here, we have the topic log, right? We have already 5 segments. And maybe segment 0 and segment 1 are it's all ordered than the time we set on the policy, and then we can offload it to the tiered storage. And this is a plus for event sourcing or CQRS. If a new tenant comes, a new bookkeeper comes, it can easily sync the data from the cold storage and then consume the new messages that are coming in through the same API without any difference. So for that, it doesn't matter. Still on the topic of a little bit about that storage, right? If we look then, the main difference with Kafka and also with Pulsar is like we have a stateful versus a stateless broker. So Kafka is a stateful broker. So every broker contains the complete log for each of the partitions in the ideal world. If the broker fails and it's not synced, the data, the logs are not completely synced with another broker, then that broker can't take over the work. Only brokers can take over the work that are in the same sync level as the other one. So in this case, brokers must synchronize the state from other brokers, other replicas of this partition to really be up to date. So it can't be before they can really take over the same work as the other broker. So that takes time. So it's not immediately that production events can continue to be sent to the consumer. In this case, Pulsar doesn't use this concept. Pulsar uses stateful brokers, stateless brokers. So Pulsar holds the data because we've seen that already in the storage layer, but just not in the broker, right? The broker only accepts the data and sends the data. So the data is separately stored in Bookkeeper. In this case, the broker can be more seen for load balancing. So for the sunshine, guys, if you hear thunderstorm, we're getting a little bit of very stormy weather now in the Netherlands. If the load gets high, then we can easily put on a new broker because the broker doesn't hold the state that's in the bookkeeper. So we can easily add brokers and divide the load immediately. So in this case, if we go from 70 million to 1 billion messages during the period, we can easily scale up if we just get some metrics and logging and all those things on the amount of messages and maybe the JVM size, the memory, CPU, all those things. This is a picture that it comes from Xenon Stack, and they have also a very good blog about Pulsar. You see there, this is like the broker itself. And with this is a plus for event sourcing CQRS, because we can always guarantee that the data is available to the consumer in real time. If if a broker goes down, we can easily put a new one next to it. Or if we need more throughput, we can put a new broker next to it. Yeah. One other thing that's more developments related with it and based on CQRS is that we have a schema registry. We can do message validation. So for CQRS, it's important that a client or producer only send known commands that we can also validate. And Kafka only supports message validation using Aflow schema. And in addition to that, if you want to do it correctly, you need to encode and decode that Aflow schema, that Aflow message in your code. So in Pulsar, we have more type safety, and within both the communication between the producer and the consumer. And for this safety messaging in Pulsar, you have both client side and server side. You have schema message validation. And how it works a little bit is that, and if we use Pulsar schema, it is applied and enforced on a topic level. And producers and consumers can upload the schemas, and they can do that. But if you do that, you need to conform to some rules. If you do create these schemas for the registry, you need to create a Pulsar schema. So it just holds, as you see, it's a JSON message. It holds a name, it holds the type, the binary representation of the schema, and it can hold user-defined metadata properties in a string stream key value map. And what is different with Kafka is that not only we have Aflow schema, but we can also do JSON schema, protobuf, which is from Google. So they have a lot of libraries about protocol buffers you can also use if it's an industry standard protocols. We can use strings, like if you want to do encoded lines in a certain pattern or a certain way they need to look like. And if you don't define it, we always have the rule bytes. Let's go over. When we can do the schema validation, right? And it's a plus for event sourcing CQRS or more CQRS, is because we only have then the messages that we want. We can cancel out any messages that don't are from that schema, right? Then if we want to, there's another thing for event sourcing and is our CQRS is that sometimes we need to perform simple computations before we send the message to the consumer. And if we want to do that with Kafka, we need, in most cases, if we do advanced things, is an extra streaming processing engine. Kafka Streams can do simple things that's in addition, but if you want to real things, you need to have Apache Storm or Spark next to it to do those things. In Pulsar, we can do it a little bit different. We can write functions in Java and Python, and we can deploy them to a cluster. And we do that without the need to run a separate stream processing engine. These functions are still lightweight. They are lightweight compute processors. If you think about serverless functions, if you hear that term, these functions, for me, it's the same thing. It's really relatable. I explain them the same way. Is that, and they are executed each time a message is published on a specific input topic. If we look at it in more detail, right, we have a lightweight compute process that, and what I said is they execute it each time a message is published. So you see, we have a published Pulsar function. This, you can apply this on multiple topics, so you can reuse it, for example, the function. And we have our specific logic. And then the output we can write to even one or more topics. So if you look at the plus for event sourcing and CQRS, is that this common logic that we have on event messages, we can use this for all tenancies and all, maybe multiple topics, multiple clusters, maybe in the geo application, and all those things without redundant programming. Maybe compare like the schema validation with smart contract rules and Pulsar functions with smart contract logic. And there's a reason why I say that. So these functions can be written in both Java and Python in two ways. You can use the native language interface, and then you don't need any Pulsar specific libraries if you do it in your code, or special dependencies. Yeah, you can do that out of the box using, for example, here the example to right from Java. It implements the function class here. But I prefer using still the Pulsar functions SDK, and this leverage the specific libraries from Pulsar. And with this, it provides a range of functionalities that are not available to the native interfaces, and that is state management. So within the context object, we can relate to already data that we have. So if something comes in, and maybe it's interesting, okay, I have a message that is valid through the schema, but is it also valid action that we can do based on the data that we already have? It's a little bit what I said is we have the smart contract, not a smart contract, but more smart asset functionality. And then we have some other reasons. I think a little bit of concluding. I see it's time already. But yeah.
Robert, take your time. If you want to talk a couple more minutes, because people are very engaged. I'm getting a lot of questions coming in. So like, if folks want to hang out a little bit longer, take your time. Go ahead.
Yeah, I think for this is a few minutes.
Okay.
So we already seen some other concepts, and because of timing, and I left them a little bit out, but the slides itself, it's that there's a difference between the concepts of Kafka and Pulsar. The first one is that, so Kafka is, you have a producer, you have a topic, you have a consumer, maybe a consumer group between those two. Where in Pulsar we have the concept also of subscriptions. So if you have a topic, you can say, right, if we have multiple consumers that listen to this topic, but if one consumer, maybe only the messages are first going to consumer one, and if consumer one is not there, we have like a failover subscription, right? It goes to consumer two. Or we have a combination that like a shared subscription that multiple consumers can take up the message, and even if then something doesn't work, we can still do a failover. So where Kafka is more focused on the streaming and exclusive messaging on partitions, there's no shared consumption. With Pulsar, we see that different, right? We have the unified message model for event topics versus the queuing patterns, where we can do the streaming to exclusive, but also failover subscriptions, because that's more functionality of queues, not something of topics. Now there's some other differences with how acknowledgements happen. With Pulsar, because you have the subscriptions, and you need to, for example, you can put in, okay, I have 2 consumers or 3 consumers, let's say 3 consumers, and at least 2 consumers need to do the acknowledge before something is, like before the state is really confirmed, and then maybe the event is really stored to the background, and that's not available to new consumers anymore. There's also a difference with retention of messages. So in Kafka, we the deleted based on retention time. So if there's no consumer, the message is deleted in that retention period, and you will lose data. And certainly with CQRS, we don't want to do that, because if we lose data, we can't rebuild the object state. So in Pulsar, there's messages are only deleted when the subscription say that okay, it's consumed by all subscriptions. So on the topic you can even have multiple subscriptions. So the message is only deleted if all the subscriptions say acknowledge. So in this case, we don't have data loss, even if there's no consumers or the subscriptions are down for a long time. So you can keep like the messages on the retention time. Even you can also keep messages longer with the retention time than if they are already consumed, right? Normally they are consumed, a message is deleted. But if you set the retention time of, for example, a year, I don't know why you do that, but and somebody picks it up, all the consumers picks it up in a day or an hour, or hopefully in some seconds, it can still be there for maybe new consumers or new subscriptions to consume them, right? And the last one is in Kafka, we don't have any time to live support. So for example, if we have like very privacy related data, and we want to say, okay, this data is only available for, I don't know, an hour, 24 hours or something like that. We can't do that with Kafka. You have a retention period, of course, you can do that with, but there's no any time to live here. And with Pulsar, we have that extra step to set that. If it's maybe secure data or something like that you want to say, okay, like a Snapchat functionality or something like that, is that okay, it's gone after a certain time. I think with that we can go to the questions if they are there, so don't hesitate to ask them.
Robert, if you want to quickly actually just stop sharing your screen, that way people can see you on the full screen.
Yeah, sure. Pause sharing, I think.
Yeah, let's pause sharing. Yeah.
Okay, can I do that? Yeah.
And then we
stop sharing.
Okay, we can see you. So, Robert, you got quite a few questions, and I also received some questions via chat as well. But do you see the little Q&A box kind of at the bottom of the Zoom? Click into there.
I see 4 questions. Yeah.
Go ahead.
Can you share a link to the blog on reason 4? Yeah, that's the one from XenoStack, I think you mean. Answer live, right? Can I do that? Or not? Type answer. Yeah. No. I answered that one. Okay. Answered also a different one. Does TTL override message retention setting then? Yeah, the TTL is a special function. So if you have like, I think you can do it even per message that you publish. So the retention time is topic based, where time to live is message based. Okay. She asked, does support the message priority as well? Does Pulsar support the message priority as well? Priority, that's something from queuing. So you have like the quality of service. It's still, the priority is still based on, I don't know if you mean it with consumption, but look, it's still a sequential log. So you have still an index that you read from. So with that, I don't know the concept of priority is how you would like see that with CQRS or something like that, because there it's
So Robert, I do see a couple questions that came in via the chat. If it's okay, I'll just read them out loud. Have a question here. What is the difference between Bookkeeper and Zookeeper? In Kafka world, Zookeeper is aimed for persistence replication among all brokers. Well, in future, Zookeeper will not be mandatory. We will see what it means in practical terms when available. Is the purpose of Zookeeper in Pulsar world same as in Kafka? That was trio.
Yes, it's the same product, right? And here, of course, it's still for the distribution of the for the synchronization of things. I think, right, the Zookeeper. It's the same. It's the same one as using Kafka, but it doesn't hold state. I think where the question is.
Yeah, the person says they're used to
Replication
Spark.
on more brokers. Yeah, it's yes, it is for replication, but not the replication to the broker. It's the replication to bookkeeper. Will be in the future. Zookeeper will not be mandatory. Yeah, I don't know this question. No, I'm sorry. I don't know this this answer. No.
Well, Robert, you sure do know a ton. You shared such great, awesome content today. Folks, before we wrap up here, if you want to just drop some additional cues in the Q&A, Robert can see those. I'll give it another 2 or 3 minutes here. Robert, I thought that the thunderstorms was just special effects in your Prezzo. I thought, you know, that's pretty amazing.
Yeah, there was one slide where something was like in the background. Oh, hey, I clicked 2 on the left side, but already was. I always try to, like, if some content is not important anymore, and certainly with where there's a lot of stuff on these slides, the comparison is to more make the other one transparent.
Another question just came in. Thank you, folks. Yep.
How to update persistent state inside of the function. So in a function you get the message, right? And you have like so if you use the SDK, you have 2 things. You have the message that's coming into the function, which is usually the command, and then you have the data already in the context where you can read the state data. So this is something you program, like in the function. If you build it with Java or Python, you can use like the objects you have there to manipulate the data and then write it with the SDK functions, write it to the new topic, stuff like that. So I would rather say this is something really very well documented in the SDK documentation of the functions. If you go to the native ones, you don't have that. So you can only receive the messages. You can't change the state. You need to really program with what you want to do with your own system or something. Maybe usually you can just retrieve it in an application, but usually it's not. Maybe for returning it to a different topic. Or you need to use a combination, but it's not easy to do something state changes if you don't use the SDK. So, but if you use the SDK, and in Java and Python, you can just program it as if you would do a normal method in Java or Python with the data changes.
So, Robert, before we wrap here, question for you. Not seeing any other Q&As. If folks just love this presentation, which I know I did, where can they go to connect with you? What's the Twitter? What's the website? What are some books? Feel free to drop those.
So for Twitter, that's my main thing. I'm almost at I think more than 1,000 followers right now.
Oh, okay.
So I think a few left, so it will be nice. But I share content not only on this, but also on blockchain, IoT, those things. So that's Robert van Mölken on Twitter. Then for the books, if you search on also my name on Amazon, or you can do it on Pep Publishing or Safari Books. From Orani is that you can find both blockchain across Oracle and the one on more on this on integration platform as a service book. This more if you want to do that kind of integrations. But and I have my own personal blog that's technology.vanmolken.nl and that's also mostly these kind of topics that you can find there.
Awesome. Well, Robert, you finished us out beautifully for today. You are our last presenter for today. So I just want to say, let me just quickly stop recording here. And then before I do that, let me go ahead and do a clap for you because that was awesome.